Welcome to another video for physical science. We're dealing with electromagnetism in this video. This idea was derived from Hans Ørsted, who discovered these properties by accident while demonstrating a science experiment with friends. So electricity and magnetism are different aspects of the single force known as electromagnetic force. So again, the root for electricity or electro, and then magnet in regards to the magnetic force that's involved. So we're talking about this particular lesson is involving and combining the two ideas of electricity and magnetism. So the electric force results from charged particles, electrons. The magnetic force usually results from the movement of electrons in an atom. Okay, so in other words, we can create a magnet by simply moving electrons in a material or electricity, right? So here I have a little diagram here. That little bronze, that bronze or the copper wire that I have illustrated there, let's pretend that I have electricity moving through that wire, and I have it moving in the right direction, as you can see by the red arrow. And as it's moving in that direction, something interesting happens. So as electricity, as electrons, charged particles are moving through a material, a magnetic field line will develop around that material. And that magnetic field line is illustrated by the arrows that I have showing here. So this is called an electromagnetic field. And it's called electromagnetic, right? It's not just merely a magnetic field like any given magnet can have, but electromagnetic because this magnetic field is developed by the movement of electrons through a material. So this particular electromagnetic field, you can see that it has a specific direction in which it goes. Okay? It has a direction in which it goes, and it's kind of going clockwise in this regard as it goes right. Now, if I change the direction of flow, the direction of the current, then I can also change the direction of the current as well, of the electromagnetic field line. Now, this particular example is best illustrated by this rule right here. We call this the right hand rule, okay? So if you hold out your hand the way that this diagram is showing, so the thumb, and you only use your right hand now, the thumb is indicating the direction of the current. So if you're holding the wire and it's like so, like I have here, then your thumb is pointing in the same direction that the current is going. And if the current is going in that direction, if you look at your fingers are actually illustrating the direction that the magnetic field line is going as well. Okay. Now you can reverse the your hand, the orientation of your hand, and have your thumb pointing down. So then if your current is going in that direction, look at your fingers. Pay attention to the way your fingers are curled. Then the magnetic field line will go in that direction as well. Okay. Now that's the principle that's involved with a wire that is straight. Now what happens if I have a wire and then I loop it? So what ends up happening, that loop, okay, my current still goes in the same direction, but what will happen is that inside of that loop, I create a magnetic field line that intensifies in that loop. Okay? So what happens if I create more loops? Well, those loops then create a very intense magnetic field inside of that loop. And this is what I call a solenoid. Okay? Back up. This is a solenoid. When I have looped coiled wire and I run electricity through that wire, I will create a solenoid. And if I put a ferromagnetic or a material that can be magnetized, if I put it like a nail, for example, if I put a nail inside of that loop, then I can essentially realign the domains of that material and I create a temporary magnet. So you can see here, with my coiled loop and with the electrons flowing through it, that material that's inside will become magnetic and a north and south pole will develop. Okay, so this is a solenoid. And this is an electromagnet. Okay, so when I have my nail attached to it, I create an electromagnet. This is a solenoid. So a ferromagnetic core, which is a material that can be magnetized, I create an electromagnet. So changing the current in the electromagnet controls the strength and direction of its magnetic field. So if I increase the current, so I have a little battery that I have there. If I have a 9-volt battery, a 6-volt battery, and I change it to a 9-volt battery, which will give me more current, then I intensify the strength of that magnet. Now, another thing I can do is I can create more loops around my ferromagnet, around the nail. I can create more loops that will also intensify its magnetic field. And if I change the battery's direction and I reverse the direction of the current, then I change the domains of the magnet as well. So to increase the strength of the electromagnet, increase the current flowing through the solenoid, and I mentioned that already, or you can increase the turns or the coils. Okay. Now, an example, some technology examples of electromagnets, as you can see here, these are the types of magnets that are used in junkyards when they're moving scrap metal. So you pump a large amount of electricity through that ferromagnet, and that creates a magnetic force, a field line, so that it creates a temporary magnet where you can move metal objects from one location to the other. So right now you can see that it's activated, and then when you want to drop that material, you'll cut off the electric current through that material, which will then delete the magnetic fields that it has, and then all that material will drop. So you can easily move heavy objects from metallic objects from one end to another by adding a current to that electromagnet. Another example is a Hadron Collider. This is a massive, massive, massive magnet that actually moves protons, subatomic particles, around a giant, I think it's a 13-mile loop in Europe. And what it does is that those magnets they create a pathway for protons to travel, and they travel in a circular pattern. And what they'll do is that they'll have protons collide with each other, and they study the collisions. They study the results of those collisions to see if there's anything smaller than protons, neutrons, or electrons. And as it turns out, kind of like if you were to have a car go in a head-on collision and it shatters as it collides, likewise, if two protons collide with each other, they end up shattering as well. And you end up seeing that these small particles are actually made out of even smaller ones. Pretty interesting stuff. And then you also have magnetic levitation trains. These are trains that are literally magnetized, and they're levitating on other magnets. So you have a frictionless way of commuting from one place to another. Magnetic levitation trains. And these trains can be incredibly fast. Okay, that does it for our discussion in electromagnetism. I hope this helped. Good luck in your studying.